Okay, so for final review unit 6, we're going to do unit 6 first because, well, we did it first in the year. So final review unit 6. Okay, unit 6 was mostly about exponents. Okay, exponents and functions. So for example 1, I'm going to ask you to simplify. And if I ask you to simplify 27 to the 2/3 power. 27 to the 2/3 power. Simplify 27 to the 2/3 power. So essentially all we have to do here is we need to start by rewriting this in power handle. Okay, so 27 underneath your radical. Power of what? 3. Handle of what?
2.
No.
Huh?
Power on top, handle on the bottom. So handle of 3, power of 2. Does it matter if I put the power underneath the radical or on the outside?
It does.
Does not matter,
No.
right? I would prefer writing it on the outside because then you do this part first. Okay, it makes it a little bit easier. So what is the cube root of 27? What multiplied by itself 3 times equals 27? 3. And then take 3 squared is 9. That's your answer. It's a little bit easier to do the handle number first. Otherwise, you'd have to do 27 squared, which, since you're not using calculators on this, would be a little difficult. I would not recommend that. Okay, let's try another one. Number 2. Same thing. I'd like you to simplify 5x to the negative 1/2 power equals 15. 5x to the negative 1/2 equals 15. 5x to the negative 1/2 equals 15. So, to start with, before you can do anything with the x, you have to have it all by itself. So, how do I get rid of this 5? So, I add, subtract, multiply, or divide. It's attached by multiplication, so to undo it, you would divide both sides. So, divide both sides by 5. That'll leave you with x to the negative 1/2 power is equal to 3. Now, 2 different parts here. We have a negative power and I have an exponent power. Or excuse me, I have a fraction power. How do you undo a fractional exponent? Reciprocal. Okay. The reciprocal of negative 1/2 is what?
2.
Negative 2. Okay. The sign, the negative, does not change. Okay, so reciprocal just means flipped over fraction. It has nothing to do with positive, negative. So when these multiply together, you're going to get the first power. So we just write x equals 3 to the negative 2. What do I do if I have an exponent with a negative in it? Make it a fraction. And then what do I do with the negative exponent? Anything attached to a negative exponent switches sides. So this is going to move to the bottom. So we got 3 to the positive 2 in the denominator. What's left in the numerator? 1. Then you can simplify. So 1 over 3 squared is 9. 1 over 9 is your answer that we're looking for. Questions on how I did that? Okay, next thing we're going to do is functions. Okay, so for example 3, if I tell you if f of x is equal to 2x plus 5, and g of x is equal to 3x minus 7. Okay, so I'm giving you 2 functions. These are basically just lines. Okay, so if you plug in x, this is what you get. There can be numbers here, obviously. If you plug in x into the g function, this is what you'd get. There's 2 parts to this question. Okay, the first one is I would like you to find g of f of x. G of f of x. This is called a function composition. So when we're working with these, you first want to start from the inside and move outward. So we need to find what is f of x. Do we know what f of x is equal to? Yes. It's equal to this whole thing. So we're going to do g of f of x, we know, is equal to 2x plus 5. Then this tells you to plug in 2x plus 5 into the g equation. So you're going to plug in for that x. So if we plug that in, we got 3 times 2x plus 5 minus 7, and then you have to simplify. Make sure that you're only distributing into the parentheses, not all the way to the end. So 3 times 2x gives you 6x. 3 times 5 is plus 15 minus 7. And that simplifies to be 6x plus 8. That's the answer that we're looking for. 6x plus 8. Now, there's also a B portion of this question. Now I would like you to find g of f of 3. G of f of 3. G of f of 3. So again, we're going to work from the inside out. So we're going to start with find f of 3. So if I wanted to find f of 3, that means plug in 3 into the f equation. Plug in here, so 2 multiplied by 3 plus 5. 2 times 3 gives you 6. Plus 5 is equal to 11. Now you're not quite done. Now we need to take this and we're going to plug into the g equation. So plug in g of 11. We plug into the g equation. You're going to plug in 3 times 11 minus 7. 3 times 11 leaves us with 33 minus 7. So what's your final answer? 26. That's the answer that we're looking for. So you're plugging in both equations. Questions on how I did that? Good. Okay, we have 6 total today, so we're halfway done. For example 4, for number 4, if f of x equals x squared plus 5x plus 2, and g of x equals 2 times x plus 1 squared, I would like you to then find f of x plus g of x. If f of x equals x squared plus 5x plus 2, and g of x equals 2 times x plus 1 squared, find the composition of f of x plus g of x. Find f of x plus g of x. So essentially, we're just going to add these two together. So if you set that up, x squared plus 5x plus 2 plus 2 times x plus 1 squared. With order of operations, what do we have to do first here? You need to, we can't really do anything that's in the parentheses, but we do need to distribute this exponent. Can I just distribute it? Can I just distribute that too? How do I actually do x plus 1 quantity squared? You have to write it out twice, and we're going to have to FOIL. So x squared plus 5x plus 2 plus 2 times x plus 1 times another x plus 1. Now, you could distribute the 2 first. I would say you should probably FOIL first. All right, so we're just going to keep writing this. X squared plus 5x plus 2 plus 2 times, if we multiply these two together, you can use any kind of format you'd like to multiply these together. I would choose FOIL. So x first times first gives you x squared. Outsides is plus 1x. Insides is plus 1x. And last is plus 1. Now, don't lose your parentheses here. Okay, if you lose the parentheses, then the 2 would only go to the x squared, and that'd be wrong. Okay, so combine your like terms. X squared plus 5x plus 2 plus 2 times x squared plus 2x plus 1. Distribute the 2, so distribute to the x squared, to the 2x, and the 1. X squared plus 5x plus 2 plus 2x squared plus 4x plus 2, and then combine like terms. Okay, so combine together your squares. So x squared and 2x squared gives you what? 3x squared. Okay, combine together your x's. So 5x and 4x is a plus 9x. And finally, combine together your numbers. 2 plus 2 is equal to 4. Now, should I factor that? Should you try to factor that? No. Okay, we're just trying to find the sum. Okay, so you're just adding things together. Once you've combined all your like terms, we are not trying to factor that. Okay, question here did not say factor, so don't. Okay, 2 more. Number 5. Number 5, I would like you to find the inverse. Find the inverse of f of x equals 3x plus 5. Find the inverse of f of x equals 3x plus 5. F of x equals 3x plus 5. So, anyone remember, how do we find the inverse of something?
I want to say we flip something.
Start by replacing f of x with y equals. So y equals 3x plus 5. Then switch the x and the y. So x equals 3y plus 5. And now you want to get y by itself. So we want to solve for y. So how would you start to solve for y? Move the 5, so subtract the 5. I'll leave you with 3x minus 5 equals, x minus 5. X minus 5 equals 3y. Sorry about that. And then finally, how do we get y by itself? Now divide away that 3. So if we divide this away, these will go away. Now, how do you write inverse notation? Do you guys remember that? We can't write y equals, but we have to actually write the original one. So f to the negative 1 of x is equal to x minus 5 over 3. So that's called inverse notation when you write the negative 1 exponent. Inverse notation equal to f to the negative 1 of x equals x minus 5 over 3. And then the last one we're going to work on today is number 6. For this one, I would like you to state the domain. State the domain of f of x equals x plus 3 over x minus 5. State the domain of f of x equals x plus 3 over x minus 5.
I'm feeling it.
So what is domain? Is domain x's or y's? Domain is the possible x values. Okay, so possible x values. So basically this is saying, can I plug in anything for x into this equation? Or are there some limitations? If you have a fraction, can I have a positive number in the bottom?
2?
Yeah. Can I have a negative number in the denominator? Yes. Okay, you can't have a negative underneath a radical, but you can have a negative number in the denominator. What can you not have in the denominator? No, we're not talking about negative, we're not talking about exponents here. But what can the denominator of a fraction not equal? It's on the green poster. 0. You can't have a 0 underneath because it would make it undefined. So basically you need to set the denominator not equal to 0. So we want to figure out what can x not equal. X could not equal positive 5, but can it be any other real number? Yes, so how do you write that? All real numbers, so the all real numbers sign, or you can write out all real numbers except x cannot equal 5. That's the domain. So for domain, you're just finding the exceptions. What can x not equal? Okay? You do have homework tonight. You're working on Unit 6 review. Okay? Don't forget that you guys